Hello dear students, welcome to the channel and very welcome to this playlist in which we are discussing about the instrumentation and sensors in detail. Up till now we have seen different type of sensors. We have seen different sensors based on their application and the range and the requirement. We have seen how do we select the sensors. We have seen why particular sensor is used in particular application. We've also seen instrumentation and different types of instrumentation. And today, after combining the knowledge of instrumentation and sensors, the basic knowledge of instrumentation and sensors, we are going to discuss about the permanent installation of a sensor and the temporary installation of the sensor. And for that, we are going to follow this PDF, which is issued by CTC Group. So based on that we are going to discuss. We are not going to discuss about the machineries of CTC, but we are going to discuss about the permanent and temporary installation of sensors in general, right? So first of all, as you can see here, they written the permanent installation sensor plays important role in the success of any reliability program. That is because once you install a sensor permanently in your system, then it will stay for a long time. It will stay for around 5, 10, 15, 20 years. And as that sensor is about to stay there for a long time, that means you have to place it well, and you have to select that sensor with very careful manner. You have to make sure that you do not select the wrong sensor, or you do not select the sensor that requires the replacement for the short duration of time, because if it does, then it would be waste of lot of capital, as well as the extra expenditure will come into the picture, because of the failure of sensor will lead to change in accessories of instrument, plus changing the mounting as well. So sometimes only because of the sensor you have to dig a hole in the wall, or you have to fabricate a new wall. So for that, the selection of the sensor which is going to be mounted permanently is very important. So another point they've written is predictive maintenance uses vibration analysis to determine the current condition of important equipment, and helps to pinpoint areas hindering it from performing at its best. So this is true for a few sensors, not for all the sensors, but vibration analysis is used to determine current conditions of whatever equipment you are using, and based on that, you can identify the areas which requires improvement, and you can improve on their performances. So basic condition monitoring is very essential for achieving maximum machine service life. This is particularly for the machines. So basic condition monitoring is very important, and to help ensure the long machine service life, it is important to determine the condition of the machinery and its bearing while it in operation only. Okay. And if your machine would operate properly, if your sensors would operate properly, then the maintenance will be very less, right? The maintenance will be less, the energy consumption of that particular machinery would be less, and there would be reduction in unscheduled plant downtime, right? So you wouldn't have to make frequent changes in your equipment or your sensors. if you plan it in advance and uh, execute it on particular sensor and their installation. On the other side, when we see the temporary installation of a sensor, it is important, but it is not it does not hold the same importance as the permanent installation of a sensor, because temporary installation, what do, you can mount a small partition in the wall, and then you can mount your sensor over it, which would be of course temporary. For temporary basis, you can use that temporary installation of a sensor when you're organizing some events, right? For an example, we all have seen this simple wiring during the wedding ceremonies, or during any small occasions in the college, or at your at our houses as well. We have seen that temporary electrical wiring, temporary electrical connection which we get, right? And based on that, sometimes what do, we have to use particular machinery, and for that we need particular sensor. For some particular measurement we need some particular sensor. So how do we fix it? Because we have the event is going to be event will be no longer than 3 to 4 days, or a week maximum. And after that, that sensor will not be useful in that scenario, right? So for that, what do, use the temporary installation of a sensor. We uh, we can build a small partition, and we can mount it over there. We can use the temporary sensors installation procedures with our small part-time projects as well. When you are working on a project, but you are not sure about its final design, right? When we are not sure about the final design of any project that we are working on. For example, let's say I'm working on a robot, that drives itself, and for that I need to use 2 to 3 different sensors. I have to mount a lidar on it. I have to mount an accelerometer in it. So I will not use the permanent installation directly, right? Because I don't know what would be the perfect place for accelerometer in that robot. I wouldn't know what would be the perfect place for lidar in that robot. So what I will do, I will use the temporary installation, and based on the temporary installation, I will determine what would be the perfect location. And once I determine what would be the perfect location of that sensor in that particular device, or in that particular robot, after that only uh, I will be making that place permanent for that sensor, right? And once you improve upon the operation of whatever equipment you are using, or whatever machinery you are using, you can work on the proper operation of it, which will again, what benefits will it provide? It will reduce the maintenance loss. It will reduce the energy consumption, and it will reduce the unscheduled plant downtime. So it would be very much beneficial for us, right? Then there will always be the need to have permanently installed sensors on critical machineries, right? If you are operating a vehicle, if you are driving a car, and you need to check whether the fuel is enough or not to move, or whether we have enough fuel or not to go to certain distance. So how do you do it, right? We don't go in the tank and check it. We have that meters, right? We have that meters which tells us if the fuel is enough or not, right? We have fuel meters, fuel which tells us if there is a fuel, if there is enough fuel or not. So it is mounted there permanently, and it is very critical because without it, if that would be mounted temporarily, and it would be fixable. If I remove it and I fix it on the bonnet of your car, if I remove it and I put it on the door of your car, then it would not be very much convenient for you to understand the how how much fuel does your tank hold, right? So the permanent installation on critical machineries is always important. And they've given some common application examples, which include turbines, fans, motors, pumps, gearboxes, blowers, right? You will see permanent installation because turbines needs permanent installation, motors require permanent installation of a sensor, right? If I'm operating a BLDC motor, and if you know, BLDC motor carries the Hall effect sensor. So what if I place the Hall effect sensor temporarily in very flexible, in some flexible position? So it would give me wrong reading of the RPM of my motor, right? So you cannot let that happen. That's why permanent installation is very important. In pumps we also use sensors. In gearboxes of vehicles we use sensors. The blowers, the coal processing equipments that processes coal, which converts the solid coal into the powder coal, right? Those equipments, if you have visited power plants ever, you would know. So similar machineries, all these machineries and other similar machineries involve critical process in a factory or a plant, and they always have permanent installation. Most of the times you will see they will have permanent installation. Now, in order to develop and implement most cost effective maintenance and condition monitoring strategy, and also to make the use of capital and operating expenditure, reliability program involving the oil and gas, aviation, rail, pharmaceuticals, utilities, and marine sectors have implemented programs that often employ permanent mounted sensors, right? So the permanent mounted sensors are used in all these places. As you can see, which places we have seen oil and gas sector, aviation sector, rail sector, pharmaceutical sectors, right? Marine sector, utility sector. In all these sectors, we will find the permanent installation of a machinery or a sensor. Again, one more point in a permanent installation, the safety is very important point here as well. So on very large machines, on giant machines, it may be impossible and unsafe to obtain the vibration data, right? You cannot go and collect the vibration data of a windmill. No, it is not possible, it cannot be done. Windmills vibration data cannot be collected. So what will you do, right? Because you cannot implement, or you cannot use the portable vibration analyzer on windmill, because it is huge, it is large, right? So its construction does not allow you to use the portable vibration analyzer, and because of that you have to go for some other ways, right? So because of this constraints, um, another example they have given, that oil supply piping, right? You cannot use the portable vibration analyzer in that as well. Similarly, machinery protection guard, steam glands, large size, small size machines, and everyday occurrence of oil, grease, and coolants present in the machine operating data makes it even more difficult. So that is difficult or even impossible. Plus, there's a fair amount of machines located in inaccessible production areas, right? Like there are some machines in the chemical processing areas which are prohibited for humans. You cannot go because the temperature would be too high or the smell would be too bad. It would not be very much convenient to go. Or there are rooms that are sealed, right? There are rooms that are close to boilers. You cannot go there. The temperature is too high. So these equipments and these conditions do not favor the application of this portable vibration analyzer, and you will not be able to obtain the vibration data of your equipment in such conditions. So what would be the solution, right? How can a responsible predictive or preventive maintenance professional obtain the necessary data from the type of machines when the plant is in full operation, right? So the answer would be the permanently installed sensors, right? With cabling leading from restricted or inaccessible area to either a junction box or a switch box or a cable terminal box, either of these boxes, right? So what we will do in such conditions, so we will use the permanently installed we will install a sensor permanently over there with a cable with it, which will lead the data from restricted or inaccessible area to a junction box or a switch box or a cable terminal box. Now both the sensor locations and the number of sensors mounted on each machine are usually determined by the criteria of machine to plant process, right? There is a criteria called machine to the plant process, and the sensor location and the number of sensors mounted on each machine are determined by this process only. Now, in order to determine whether a machine requires a permanently installed sensor or an overall maintenance strategy using machine status, classification system is often implemented, right? So first you want to determine whether machine requires permanently installed sensor or a temporary installation of a sensor. What would you do? An overall maintenance strategy and of using this machine status classification system will you will be implementing that. And how do we implement that? We have three stages, or there are three ways we can classify it, and then we can determine whether my equipment will require permanent installation of the sensor or the temporary installation of a sensor. So the first point would be the run to fail maintenance. So run to fail maintenance occurs when repair action is not taken until a problem results in a machine failure, right? So run to fail problem often causes costly secondary damage along with unplanned downtime and maintenance cost. So this is one of the severe faults. You can see them similarly as you see the severe faults in power system, right? Because these failures will will be unpredictable in a way, will cost you a lot in maintenance, and the downtime will be too high. You may have to start your machinery from the scratch. And if you are having a small machinery or small instrument, it is easier. But when you are running a power plant, it gets difficult, right? So run to failure maintenance, you have to check right? When repair action is not taken until a problem results in a machine failure. So uh, there can be a situation when there is a failure or a fault in your sensor, and you don't take any action. For an example, let's say if you are having a car, or you're having a computer, and you do not and you're having some scratches blinking on your screen, or you're having a black screen on your screen flashing over, and you do not take action, but it was and it gets severe in with time, and it will it will it will it will damage your display, right? It will damage the display of your phone or laptop, and because of that, it would be too costly to repair your phone, or it can even be impossible to repair a phone, right? And the time requires will always again will be more. Nowadays we have better equipment, so time required will not be too much, but uh, the maintenance cost will be too much. So that you can relate to run to failure maintenance. Then we have the second point, the preventive maintenance. So this preventive maintenance is the process when a machine or a part of a machine are overhauled on a regular basis, regardless of the condition of that part, right? So sometimes what happens, there are some certain parts of a machine which are used very more frequently than the other parts, right? Just like keys on your keyboard, there are certain keys on your keyboard that would be used that would be used more frequently by you on your computer compared to other keys. Just like the apps on your phone, same ways, right? We use some of the apps very frequently, and we don't use some of the apps very frequently. Same thing will happen with the instruments as well. There are some instruments in the whole system that will be used more frequently, and the sensors of that instruments will also be used more frequently, and because of that too frequent application of that, it will it will get more stress on it, and are overhauled, right, on regular basis, regardless the condition of the part. And because of that, the condition of the part can go from bad to worse very quickly, and that if you don't take the preventive maintenance steps, it will fall into the category of run to failure maintenance. So with this, preferable to run to failure while this is preferable to run to failure maintenance, preventive maintenance is costly because of excessive downtime from unnecessary overhaul, and the cost of replacing possible good parts, right? If your instruments fall into run to failure maintenance, then what do you have to do? You have to sometimes start your instrument or your system from the beginning. But in preventive maintenance, your system is still working. It's just one part that has been overhauled, and it needs replacement. So what do you have to do? You have to identify it, and once you identify it, you simply have to replace it, right? Or if it needs some furnishing, if it needs some maintenance, that particular part needs some maintenance, then you can complete the maintenance work of it, and then put it back, you can fix it back, and your system will be start running like before in no time, right? So that is preventive maintenance. And then we have the predictive maintenance, right, which you can plan. Predictive maintenance is something that you can plan of. So predictive maintenance is a process by the way, you can also plan the preventive maintenance if you have a idea of the idea of the instrument itself. If you are well aware of the instrument, then you can predict the preventive maintenance as well. But predictive maintenance can be predicted very easily. It is a process of determine the condition of machinery while in operation itself, right? And it will enable the repair of the problem components prior to failure. So conditional monitoring not only helps the plant personnel reduce the possibility of catastrophic failure, but it will also allow them to order parts in advance, schedule manpower, and plan other repairs during the downtime, right? So you can predict based on your knowledge of that plant, or based on your knowledge of that system or instrument, that this instrument will be requiring maintenance is in this much amount of time. And based on your prediction, you can arrange the parts which are down. You can arrange the overhalted plants, because you can predict what sensor will be what sensor will be overhalted. You can predict what part of that instrument will be overhalted, and based on that you can take steps, right? You can schedule manpower, you can arrange the time, you can make your arrangements based on how much downtime you are going to have, right? So you can also order the parts in the advance, so that will give you a luxury to complete the tasks that are complete the tasks that do not fit with the predictive maintenance, right? You can even arrange an alternate for it if your plant is not very costly and uh, not exclusive. So these three statuses you first check, and based on that you select what type of installation you will be required. And once it's been determined which machines are selected for permanent sensors, then the vibration analysis can take place. The vibration analyst can then decide how many sensors are required, and for each machine, like motor or fan or pump or AC, anything, it should have at least one axial sensor and one each horizontal and vertical sensors, right? Whether you use the permanent installation or the temporary installation, this is a general practice which the people who mount the sensors follows, that your equipment should have at least one axial sensor. As you can see, this here is the axial sensor, right? And one each horizontal and vertical sensors. So you can see horizontal and vertical sensors. And sometimes on the critical machines, if it is preferable to have one axial sensor per machine and one horizontal and one vertical sensors per bearing as well, right? So it depends on the equipment actually how you mount your sensor, and also it depends on the requirement how you mount your sensor permanently or temporarily, and how you can get the best of it. You have to determine how you get the best of it based on these three classified tests: run to failure maintenance test, preventive maintenance test, and predictive maintenance test. It's not exactly tests, but you can also call it test based on how you are taking the analysis. You can also call it analysis, right? Now if the machine in question has a backup and will not cause a plant shutdown, then one axial sensor and a horizontal sensor on one bearing with a vertical sensor on the remaining bearing should provide sufficient baseline data for the most situations, right? Repeating, so if my machine in question, or the machine on which I'm planting the sensors, has a backup and it does not cause a plant shutdown, then one axial sensor and a horizontal sensor on bearing and a vertical sensor on the remaining bearing will be enough to provide the baseline data for most of the situations, right? So the first chapter, we are wrapping the first chapter here today. With next class we will be starting the second chapter. If you have any doubts, queries, please mention them in the section, in the comment section below. Any type of feedbacks or suggestions are welcome as well. So if you have any feedback, you like the lecture, you don't like the lecture, if you want me to change the method of elaborating, so please mention that in the comment section below as well. I will be seeing you next time with the new chapter. Thank you very much for listening. Goodbye for now.